Good day everyone, I am Eileen Beck Boras from BSI Sciences 3 and together with me in making this activity is Mary Gwen Soto. She is in charge for the part 2 of this video requirement for Scied 59. For the part 1 of this video entitled Matter as a Minute Particle, we are going to perform 3 activities or procedures. For the duration of this part 1, we are going to need 3 empty bottles, sand, water, and 3 balloons. For procedure 1, we are tasked to get a cap and uncap empty bottles and squeeze it out to observe what happens. To answer the hypothetical question, do you think the bottle is completely empty? The answer is no. Both bottles contains gas, and gases are known to spread out more than solids or liquids. The vibrations in gas molecules are at higher rates, so no matter the size of a bottle, a gas will enter in it. Therefore, the caped bottle had an enclosed gas on it, which makes it hard for the gases to escape since there is the bottle cap preventing it to escape. Whereas the uncaped bottle is free of gas entry and exits because there is no cap bottle that hinders the air or gas from escaping. Let us now proceed to procedure number 2. For this activity, we have 3 bottle labeled A, B, and C respectively. For bottle A, we are going to remove the cap and put a balloon on top of the bottle. What happened to the balloon when you squeezed the bottle? So, the balloon expanded in size. How can you describe the behavior of molecules when you squeeze the bottle? The moment I squeezed the bottle and the balloon expanded, the air or the gas in the bottle was pushed to exit towards the balloon, and the constant vibrations of gas molecules pushed through the walls of the balloon, making it appear puffed or inflated. For bottle B, we will fill the bottle with water and put a balloon on top, securing it tightly. So I have filled the bottle already with the water, so let's just put the balloon on top of it. So what happened to the balloon when you squeezed the bottle? The bottle had gathered, the balloon had gathered the water that escaped from the bottle's neck. And how can you describe the behavior of molecules when you squeeze the bottle? The molecules of liquids vibrate, but not as much as energy of those in gases. However, they are close together and will slide over one another. The air pressure between the bottle's neck and the balloon had caused the balloon to vacuum the water that had escaped from the bottle. Were you able to squeeze the bottle filled with water as much when there was only air in the bottle? Explain why. I wasn't able to squeeze out the bottle as much as bottle A because the pressure of the water might cause the bursting of the balloon. The attractive forces between particles are strong enough to hold specific volumes only. For bottle C, we are tasked to fill the bottle with sand and put the balloon on top. As you can see, I have already filled partially the bottle with sand, and I only filled it partially because I have shortage of resources. So now, all I will do is put the balloon at the neck of the bottle. And let's try to squeeze it out. So what happened to the balloon when you squeezed the bottle? The balloon had almost no inflation happening because my sample had a gap in the balloon. The balloon had inflated a little. But however, it was not completely filled. The balloon wouldn't be inflated. So how can you describe the behavior of molecules when you squeezed the bottle? A solid molecule is closely packed together and they cannot move nor vibrate. Since solids are immobile molecules or have little to no movements at all, it is harder to inflate the balloon or make a gas escape from a solid container or solid state. So the last question, were you able to squeeze the bottle filled with sand as much when it was empty? Explain why. I wasn't able to squeeze the bottle as much, as you can see, because of the solid molecules giving me restrictions to squeeze out the bottle. Solid molecule movements are little to no movements at all. Therefore, the balloon did not inflate because there is not enough gas to inflate it, to make it inflatable. Describe how the molecules of a liquid act differently from the molecules of gas. So gas molecules have a lot of distance with each other. Therefore, there is no regular arrangement of molecules. Liquid molecules are closer together and still has no regular arrangement of molecules. However, liquid molecules have a definite volume but no definite shape, whereas a gas molecule have no definite volume and no definite shape. Thinking about your models of molecules in a gas and liquid, why do you think a closed bottle gas is easier to squeeze than a closed bottle of liquid? So the nature of gas molecules are farther apart from each other. They constantly vibrate and move freely in a container at higher speeds. A closed bottle of gas is easier to squeeze due to the free and fast movement of particles present in the container. So this concludes the part 1 of this video requirement in Scied 59. Now let us proceed to the part 2 made by Mary Gwen Soto from BSEd Sciences 3 as well.
Hello everyone, good day. I am Mary Gwen Soto from BSEd Sciences 3. So this activity is entitled Matter in Motion, which today we will know or we will discover if the speed of water molecules different in hot and cold water. For the hypothetical question, is the speed of water molecules different in hot and cold water? I think yes. Different water temperature, also different level of energy of the molecules. So this is the container for our cold water and for our hot water. So let me pour the cold water here. And the hot water. One drops of yellow, blue, so let us observe what happened. For question, are the molecules moving faster in cold or hot water? As what I had observed, the molecules are moving faster in a hot water. The mixing colors in the hot water moved around and mixed more than the food coloring in the cold water. I think this is because hot water has greater energy, and this heat energy from the water creates the molecules to move at a quicker rate. So, what does the speed of the mixing colors tell you about the speed of the molecules in hot and cold water? The speed of the molecules in hot water are moving faster, so that when we are going to put the food colors, they mixed faster than in the cold water. While the speed of the molecules in cold water are moving slower, that's why when you put the food colors, they mix slower than in hot water. That would be all. Thank you for watching. May God bless us all.